Welcome, pre-algebra class. This is, the last lesson, which will lead us into our summative project for this unit. This is on simple and compound interest, lesson 5, 281, if you're following along. So, interest. What is interest? Interest is the money that you have to pay to the bank for loaning money. So let's say that you want to buy a house and you need more money than you have to buy the house because you don't have enough money to buy the house completely all at one time. Or maybe you just don't want to because you have the money but you don't want to give it all to or spend it all to buy the house, and you want to have some left. You can spend a little bit at a time. So in any case, when you borrow money from the bank, this is how the bank makes money, because the bank doesn't really sell anything, right? Their service, the thing that they, what they provide, the same way that a school provides education or a Nike store provides shoes, what they provide is borrowing money. So when you go borrow money, and let's say you borrow $10,000. Well, when you pay the bank back, you don't pay $10,000 back. You might pay $15,000. And so this $5,000, that's more than $10,000. That's the interest. That's how the bank makes its money. So there's a type of interest called simple interest. And simple interest is only paid on the principal. The principal is the original amount that you borrow, which is the $10,000. So let's say you borrow $10,000 and then you pay back $1,000, right? So you pay back $1,000. Then there's $9,000 left of principal. Okay, so how we figure out principal, how we figure out simple interest is with this equation, where interest equals the principal times the rate times time in years. So the amount of money that the bank earns, the interest, is equal to the amount of money that you borrow multiplied by the interest rate, which is a percent, and then a number of years. So let's take a look at an example. And I'll keep this equation down here so you can see it. So let's say that you borrow $10,000 and the loan rate is 0.45%. And you borrow it for 2 years. That means you pay back, let's say, some amount of money every month for 2 years. So you pay back 24 times. So how would we do that? Well, we would place $10,000 as the principal. So $10,000 multiplied by the rate, which is 4.5%, which is 0.045, right? Because we moved the decimal place over 2 places to get the decimal. And then we multiply that by the number of years, which is 2. So those things multiplied together is equal to $900. So this is the amount of interest. So when you pay back the loan, you're going to pay back your $10,000 that you borrowed plus $900. So this loan is going to cost you $900. You'll pay back $10,900. Okay. The second one, $25,000 multiplied by 0.0675 multiplied by 3 years. Let's see what that is. 25,000 times 0.0675 times 3. And so this equals $5,062 and 0.5. So we're going to round that up to $5,063. This is the amount of simple interest. Okay. Your turn. Find the simple interest rate, round to the nearest dollar. So this one is 2250 times 0.06 times 4, which is $540. So that is your simple interest. All right. Let's look at a real world example. Let's say that Isaac borrows $18,600 to buy a computer. He will pay $713 per month for 30 months. So we don't have the same information here, right? We have the principal, which is $18,600. We also have the amount that he pays every month for the number of months. So this is the total loan. So as you can see here, this is 30 months out of 12 months in a year, right? So this is 2 and 24, 6, 2.5 years, right? So how I did that was, we need to find out how long 30 months is. So there's 12 months in a year, so we divide 30 by 12, and we get 2.5. So we're going to multiply this by the rate, which we don't know, right? And then we're going to multiply this by 2.5. And this is going to be equal to 713. Now this is 713 times 2.5. Right, which is 1996.4. This is the total amount that he's going to pay in his simple interest, right? Because if he pays this much every month for 2.5 years, which is 30 months, that doesn't make any sense. I did this incorrectly. 713 times 30 is 21,000. What am I doing here? What am I doing here? Not doing it right. That's what I'm doing. 21,390 minus 18,600. So you take the amount that he pays back every month and you multiply by 30 to figure out how much he's paid, right? But how much he's paid includes the original amount that he borrowed, which you have to subtract back out. So that's 18,600. So that's 2790. What did I say earlier? I don't remember, but this is the correct number. 2790 equals 18,600 times R times 2.5. So if we want to figure out what R is, we have to solve for R, which means we need to get R by itself, which means we need to move everything else away, right? So these are all multiplied by each other. So the way that we move things that are multiplied is by dividing them. So 18,600 multiplied by R, in order to get rid of that, you would divide by 18,600. Divide by 18,600. So divide by 18,600, and that would give you 0.15 equals R times 2.5. And then we'll do the same thing again. Divide by 2.5. And that gives us an R of 0.06, which is 6%. This is the interest rate for his loan. Okay, so I'm going to walk you through all that again. This is the principal. This is how much he pays in total every month for 30 months. So you multiply these two together to get how much he pays back Then you subtract back out the 18,600, which is how much he borrowed, to get the amount that he pays in interest, right? Then you write that into the equation. You know the interest, you know the principal, you know the amount of time. The time is 2.5 because that's 30 months in years. You divide it by 12 is 2.5. And then you divide by 18,600 and you divide by 2.5 on both sides to get 0.06 equals R, which is 6%. Okay. Your turn. Suppose Victor placed $24,000 in the bank for 5 years. He makes $92 in interest each month. So in this example, Victor is actually the one making money, because how does the bank get money that they loan to other people? Well, they get it from you. So when you save money at the bank actually takes that money and lends it out to other people. And so we can talk about the specifics of this later and how they get away with that, because what happens if like everyone takes money out at the same time? So $24,000 is the original principal, right? And we don't know the interest rate, and he does that for 5 years. And he makes $92 each month. So 92 each month times 12 months times 5 years. That's how much interest he ends up making, right? 92 times 12 times 5 is 5520 equals 24,000 times R times 5. Then we divide this by 24,000, and then we divide it by 5. So that's 0.23 equals 5R. Then divide by 5. That's 0.046, which is 4.6% interest, which is amazing. That's a huge interest rate. If you could get 4.6% from the bank, then do it, because it's guaranteed money. You're making that much money. Okay, compound interest is interest paid not only on the principal, but it's the principal. In fact, this shouldn't say only, it should say paid on the principal and the interest rate earned in the past. So what does that mean? That means that if you were to borrow, let's say $1,000, and it accumulates some interest, okay? So let's say that after the first month you don't pay anything, and that it becomes $1,010. Well, now you pay interest on this amount. And then the next month, it's not going to be plus $10 anymore. It'll be slightly more than that. And so as time goes on, your interest becomes more and more, because the amount that is multiplied becomes more and more. So let's look at this equation. This is compound interest equals the principal, times 1 plus the rate over the number of years to the number of years. Oh no, n is not years. T is years. Sorry, hold on. Yeah, sorry. So this is actually number of times compounding to the number of times compounding times the number of years. Okay, so what does this mean? The thing that's different now is that we have this number of times compounding, right? Whereas before, we had the number of years, we had the rate, we had the principal, we had the interest earned, but now we have this new variable, right? And this is, so let's say that your loan is for 2 years. Well, then the T would be 2. But during these 2 years, your interest would be calculated, let's say every month. So if it's calculated every month, it's calculated 12 times, right? And if it's calculated 12 times, then N is 12. If your interest is calculated every day in a year, then it would be 365. If it's calculated twice a year, it would be 2. Okay? So let's take a look at an example. Let's say that Jan invests a $600 home ball in a certificate of deposit. So he gets $600. Let's say it's his birthday. He gets a home ball from his grandma, and so he puts it into what's called a certificate of deposit, which is one of the ways that a bank makes sure that you don't take money out of the bank. Oh, I just realized I haven't been speaking into the mic, so it's going to suddenly get louder. So, so the bank, they don't want you to just put money into the bank. They want you to put it into something like a savings account. And a savings account is an account where the amount of money in the account can't ever drop below a certain amount. Or they want you to use something like a certificate of deposit or another product. They have a lot of different ways of doing this, but this is one way. And what a certificate of deposit is that they say that they're going to give you some amount of money. In this case, it's 8.75%. And the money is going to be locked away for 10 years. You cannot touch it for 10 years. And this way, they can take that $600 and they can lend it to someone else for even more interest for 10 years. So that after 10 years, they've given you your interest that you earn, but someone else has given them even more interest. So let's take a look at our equation. So our compound interest is equal to the principal, which is $600, multiplied by 1 plus the rate, which is 0.0875, over the number of times it compounds in a period. So it compounds every year. And how many times does it compound? It's compounded annually. Annually means every year, once a year. So it's just going to be 1 over 1 times the number of years, and the number of years is 10. So this means that it's going to be 600 times 1 plus, and this number over 1 is just the same as that number, right? 0.0875 to the 10. 1 times 10 is 10. So this is simplified. Now we can add these two like terms. So this is 1.0875 to the power of 10 times 600. So let's see what that is. 1.0875 to the power of 10, which is 2.3136, so on and so forth. There's a bunch of numbers here. I'm not going to write all those numbers out. And then I'm going to multiply that by 600. And that's going to give me A, which is $1,388. Rounded to the nearest dollar. It's 0.17, so on and so forth, but we can just, it's rounded down. So he made $1,388. No, I'm sorry. A is not the compound interest. A is the final amount. The final amount in his account. So he had $600. It turned into $13,800. 1388. So if you take 1388 and you subtract 600, $788. He made over 100% on his investment. He put in $600. 10 years later, he has $788. That's how you grow your money. So let's look at the basic simple interest, which is I equals PRT, right? So if we had done this, where we had $600 times 8 or 0.0875 times 10, then what would that be? What would that be for simple interest? 600 times 0.0875 times 10 is $525. So look, 788 minus 525. He made an additional $263. $263, which is like almost 50% more than this, right? Yeah, very close. It's just about 50%. He made 50% more putting it into a compounding interest account rather than a simple interest account. Okay? All right, your turn. Let's say that Jay invests a $5,000 home ball into a stock account with a compounding interest rate of 5% compounded annually. Again, annually, that's one time a year for 5 years. What is the total amount of money in the account? So that would be 5,000 times 1 plus 0.05 over 1 times 1 times 5. So that's 1.05 to the power of 5 times 5,000, and that equals 6,381. $6,381. Remember that if you're doing this with US dollars, which is what it is in the textbook, because we're doing this in NT dollars. If you're doing it in US dollars, though, there are decimals and there's cents, and there's US dollars there's like 2 spaces after the decimal. So even if you have 1.1, you cannot write it like that. You have to put another 0 there. It has to have 2 numbers after the decimal. This is for US dollars, which is what the textbook homework is. Speaking of, the homework is page 283, 284. All right, see you later.